Hello guys and welcome to a new video. Today we're going to talk about the same project, which is divided into two parts. One of them is the physical model of the heart and the other one is the PC program where you can play and learn more about the circulatory system. The main purpose is to develop a teaching model capable to communicate in a different and innovative way the variety of processes inside the human body. First, let's go to the physical model.
In order to create our model, we need these materials. Foamies in colors red, pink, blue, white, acrylic paintings in colors blue, red, black, white, and yellow, pencilings, a pen or a pencil, silicone gun, scissors, cutter, drawings of our design of the model, dry ice, and cardboard in order to paste the model. The first thing that we need to do is to design our model. Then we need to draw in a pink foamy the shape of our heart and cut it. From the first piece of paper in which the drawing of the model is on it, we need to cut each single part of the heart. Then each part of the heart we need to paint it with the black paintings and the white paintings. Then on the cardboard you will also need to draw the heart and cut it too. The next step is to paste the little pieces on the red and blue foamy in the edges of the drawing. Then we need to paint the inner parts of the heart. After this, on the pink foamy in the inverted part of it, we are going to paste the little pieces of the red foamy in order to give it a little bit of volume. The next step is to join both sides that we already have. The pink one with the drawing in the cardboard with the red one in the cardboard. Then we should repeat this step with each one of the parts of the heart. Now it is time to paste the painted parts on the cardboard in order to start building the structure of the heart. The next step is to make little cylinders with the red and blue foamies in order to simulate the veins that transport the blood. These tubes are going to paste it on the external edges of the heart. Then in a wooden plank we paste the entire heart already built. And finally, we paint that wooden plank with a black painting.
In the part of the program, we are not going to explain it deeper, because it will be tedious and not easy to understand, but we can divide it in several steps. First, we got all the necessary information from different sources in order to put it in the program. Then we designed animations, the sound, voices, and easy ways to express that information. Finally, we started designing a game in which the user can apply what he has learned. It looks quite simple, but believe me, it was not. Really, it wasn't easy.
The left ventricle is the lower left-hand chamber of the heart. Together with the right ventricle, it forces blood of the heart into the arteries to be carried back to the various sides throughout the body. The left ventricle has a much thicker wall than the right ventricle. It must force blood to all other parts of the body against a great flow of resistance, so the walls are stronger than that of the right ventricle. The left atrium is one of the four hollow chambers of the heart. It plays the vital role of receiving blood from the lungs via the pulmonary veins and pumping it to the left ventricle. The right atrium is one of the four hollow chambers of the interior of the heart. It is located in the upper right corner of the heart superior to the right ventricle. The oxygenated blood entering the heart through veins from the tissues of the body first enters the heart through the right atrium before being pumped into the right ventricle. The right ventricle is the lower right-hand chamber of the heart. Together with the left ventricle, it forces blood out of the heart into the arteries to be carried back to the various sites throughout the body. The right ventricle has a much thinner wall than the left ventricle. This chamber pumps blood a fairly short distance to the lungs. The left pulmonary artery is also known as the left branch of the pulmonary artery. It supplies blood to the left lung, it runs down to the root and the lung, and from there it branches out into two separate arteries. These smaller arteries each transport blood to one of the lung's left lobes. The right pulmonary artery is also known as the right branch of the pulmonary artery. It is a thicker artery and a longer one compared to the left pulmonary artery. The right pulmonary artery provides the right lung's blood supply. It runs down to the root of the right lung, and from there it branches out into two separate arteries. These smaller arteries each transport blood to one of the lung's right levels. The inferior vena cava is the largest vein in the human body. It collects blood from veins serving the tissues inferior of the heart and returns this blood to the right atrium of the heart. Although the vena cava is very large in diameter, its walls are incredibly thin due to the low pressure exerted by venous blood. The superior vena cava is one of two major paths into which the veins from all parts of the body, except from the lungs back to the heart, converge to lead to the right atrium of the heart. Pulmonary vein is a vein that carries oxygenated blood from the lungs to the left atrium of the heart. The aorta is the main trunk of the arterial system, conveying blood from the left ventricle of the heart to all of the body except the lungs.
Hemoglobin is the protein that transports oxygen in human blood from the lungs to the tissues of the body. Proteins are formed by the linking of amino acids into polypeptide chains. An individual amino acid in a protein is known as a residue. Each subunit contains regions with a colloid shape. Many of the amino acids that make up the polypeptide chain interact to form this particular structure, called an alpha helix. Each amino acid is hydrogen bonded. And this is the process of respiration in blood. First, blood rich in carbon dioxide is pumped from the heart to the lungs through the pulmonary arteries. Arteries are blood vessels carrying blood away from the heart. Veins are blood vessels carrying blood to the heart. In the lungs, CO2 in blood is exchanged for oxygen. Then the oxygen-rich blood is carried back to the heart through the pulmonary veins. After that, this oxygen-rich blood is then pumped from the heart to the many tissues and organs of the body through the systemic arteries. In the tissues, the arteries narrow to tiny capillaries. Here, oxygen in the blood is exchanged for carbon dioxide. The capillaries widen into the systemic veins, which carry the carbon dioxide-rich blood back to the heart. Considering what happens with tissues, here it is possible to observe how carbon dioxide, hydrogen, and the anion of chlorine exert a negative effect on the union of hemoglobin and oxygen. Cellular metabolism produces oxygen, which diffuses in the blood and enters to the red blood cells. Inside of them, the CO2 converts quickly into carbonic acid because of the action of carbonic anhydrase, as shown below. Maintenance of blood pH. Carbon dioxide reacts with water to form a weak acid, which is called carbonic acid, which will cause the blood pH to fall to dangerous levels if it were not promptly removed, as it is excreted by the cells. This is accomplished by combining it with carbonate ion through the reaction, which is forced to the right by the high local CO2 concentration within the tissues. Once the hydrogen carbonate, which is called bicarbonate, ions react the lung tissues where the CO2 is partial pressure, which is much smaller, the reaction reverses and the CO2 is expelled. Hemoglobin is a great example of how chemical systems in blood distribute necessary molecules to the cells through the body and remove wasted products from those cells.
During the making of the project, the team realized that not a single cause affects the circulatory system. However, we realized that one of the factors that alters and causes diseases in greater amount is the cholesterol, because it blocks the blood's path. With this project, we also want to discuss this and give you tips of prevention. As you could watch in this video, our project is clearly defined, but we need to complete it by improving some aspects. At this point, we have already the model to explain and the puzzle that students who'd rather perform activities than listen or watch will use. The program and its video games, which are focused on people who prefer listening or watching, it's still in process, as it took more time than we thought it would do. My role in the project was as an organizer. I distributed the responsibilities and was in charge to assure that all the aspects were covered by the team. I also helped in the selection of information, explanations, and making the puzzle that we already saw.
In this project, I was in charge to explain the relation of the circulatory system with the lymphatic system. At the beginning, it was a little difficult to understand, but it was interesting. With the information, we will draw part of the model of the stem. Despite of how we interpret the information, there was not any difficulty in this part.
For this project, I was in charge of getting all the materials needed for the physical part, and I also helped painting those parts. The other thing that I did was a research on the chemical reactions of our system. For this project, I was in charge of getting all the materials needed for the physical part, and I also helped painting those parts. The other thing that I did was a research on the chemical reactions of our system.
In this project, I help my team making the physical part of the stem. I investigate about the most important part of the heart and their functions.
For this project, my responsibilities were to perform and build the explanatory model and also the puzzle, the didactic model. Also, I help in the research of information needed for our project. And all that I can say is that this is an excellent team and we are going to do our best effort in order to be the best team to present our project.